All right, everybody, welcome back. Today, what we're going to talk about is how we take regular expressions and generate finite autonoma from them. Sometimes it's going to be really simple, but it always evolves into drilling down to the smallest piece and then using that to expand out to the full regular expression. So we're going to start with those small pieces, and then I'm going to show you kind of how we build out to that. All right, so let's get started. We're going to start off with terminals, right? And so if you were just trying to recognize the terminal A with a finite autonoma, if that was your regular expression, you would just draw something like this, right? So I'm not going to draw the arrows here. I will draw a couple of these except states, but I won't draw the beginning states because it'll be pretty obvious for a second. If you had concatenation, then you would take the end state of this A and you attach whatever the concatenated piece is. So when I have a piece and I want to append a concatenate something to it, then I'm going to start at its accept state and then append the new piece to it, whatever the new expression is, right? For AA, it's pretty straightforward. If I have an OR, what I'm going to do is I'm going to generate a new state. This is like a start state for the OR. I'm going to branch out in both directions as a guess using an epsilon transition. And then each of those will be like normal. So you can see kind of the AA part is up here, the BB part is over here, and then the OR part of it is this epsilon where I say, hey, either you go this way or you go this way, and they don't interact with each other, and that's okay. Okay, the star part is where it gets interesting. So let's kind of show this whole thing here. So if I've got something like AA star, how do I do that? Well, what I'm going to do is I'm going to start with the AA that I had. I'm going to make an epsilon transition from that old accept state to the beginning state. And then I'm going to move kind of the accept state for AA from where it was, which was over here, to the beginning. And so the reason this does a star is because, hey, I start in the accept state, which is great because star allows you to take that loop 0 times. And then every time I take the loop, I end up back in the accept state. And I call this a loop because my brain is thinking ahead a little bit, and it's kind of a hint. But it is a loop if you look at it, right? Like this is a pathway through the machine that is loopy. So if I want to do AA star, I move the accept state to the beginning state, and I make an epsilon transition from that old accept state to the new accept state, the beginning state, and suddenly we have a loop here, right? Now this gets more complicated when we're pushing pieces together, so let's do a full example. It's actually the colors make it maybe a little hard to parse, and my video is going to cut us off a little bit. Here we go. So I've got 0 or 1, 0 star 1, and then all of this starred. The way that you build this up into a finite autonoma is you start at the simple parts. The simple parts are these 3 terminals, these 3 variables, these 3 symbols from the alphabet. So what you can see here is I've got my 0, right? This is the beginning of the 0. This is the accept of the 0. I've got that same thing over here for the 0 star. I've got that for the 1. I've got that for this one. Now, I made some of these attachments already, and building this up slowly makes more sense. So let's go ahead and do that. So if I'm looking at the 1 followed by 0 star, well, when I start to draw my 0 star, remember, I took my accept state and I moved it back over here. That's now my end state for the 0, and then I draw this epsilon here. So this is 0 star. Whatever follows after this 0 star is going to follow out of this state because this is my final or my accept state for the 0 star. And so that's why this 1, this purple one here, comes off of this state and not from this one, because actually this is the end of the loop, either because I didn't take the loop or because I'm done taking the loop 0 star times. So then I come over here and I accept my 1. I eat my 1. Okay, now that's 1, 0 star, as many times as I want, 1. Right? And this is 0. Now that's the inner part. This was an OR, which means the beginning is this, and it has epsilon transitions. So now I've got either 0 or 1, 0 star, 1. And then I have this star here, which means my accept states, which were this state here and this state here, now become empty string transitioned to the start state of this whole expression. So you can see these epsilon transitions here. They have come from this gray star right here. And then that accept state becomes, that beginning state becomes an accept state. And so it is the only accept state left in my diagram because the 1, 0 star 1 ended here and I've moved the accept state over there. And then the 0 star moved over here. Now let's process some strings in this language. If you had the string 0, 1, 0, 0, 1, right? You would say 0, 1, 0, 0, 1, and that would land you in the accept state because you get to take epsilons for free. There are many, many other paths that you would take if you were processing 0, 1, 0, 0, 1. That's okay. We only need one accepting path, which is why these things are guesses, which is kind of great. Okay, so we're off to your turn. What we're going to do is convert these regular expressions into finite autonoma using this construction method. So here's your first one. Go ahead and pause the video and check this out. 0, 1 star 0 or 1, 0 star 1. We can also think about what the language of this is. And if our finite autonoma that we end up getting looks anything like what we think we would draw, because I think that is interesting. So go ahead and pause it and come back, and we'll draw this one together. So we've got 0 followed by 1 star, followed by 0, which looks like this. And then we have the bottom part, which is 1, followed by 0 star, followed by 1, which looks like this. And then those are ORed together. So what I'm going to do is make a new start state over here and OR them together. And then it turns out these are actually final states of the whole machine. So either our string is 0, 1 star 0, or our string is 1, 0 star 1, like this. It's pretty cool, right? All right, let's move on to our next one. How about 0, 0 or 1 star 0? This is important because 0 or 1 star is going to show up a lot, as we saw. So go ahead and pause and then come back and we'll see what we get. So we've got 0. Now we have 0 or 1 here. So technically the way you do 0 or 1, right, was we would have a 0 and a 1, and they'd be ORed together. But I'm going to go ahead and OR them together out of this state because that's where they're coming from. And then it's starred, so these accept states move over here, and I have to draw epsilon transitions. This is definitely not how I would draw 0 or 1 star. It is not how any of you would draw 0 or 1 star. But this is the automated way where 0 and 1 star would come out of. This accept state is now our kind of last state, so it's not actually an accept state. It just leads us out to our final 0, which is an accept state. So now this becomes 0, and then 0 or 1 star. As many times as we have to take these loops, we will, followed by 0, and that's what that looks like. I'm going to leave you to do some on your own. So here's one that's pretty cool and give you some reasons why regular expressions might show up in your life somewhere. So this is the regular expression that is www dot, and then this is any character, any alphabetic symbol, and then any alphabetic symbol star dot edu, followed by slash any alphabet starred as many times as you want. And the question is, can you construct this finite autonoma using this method? And then you can go ahead and pause and try that out. I'm not actually going to do that one on stream here with you. And another one that you might think about that might be a little bit easier if you want to get your feet wet on a slightly easier problem, and we'll use D to mean any digit, would be digit followed by digit, followed by slash, followed by digit, followed by digit, followed by slash, paren 201 followed by any digit, or 202 followed by any digit, end paren. So this would be any date from 2010 through 2029, right? That's what this symbolizes, is any date in those ranges, which is kind of neat. And you might think of reasons why you might want to use something like this in a verification in a web form or something else. Okay, we'll leave it there so we can stay under 10 minutes, which is amazing. So I'd like to say, as always, be kind to each other. And in order to do that, you have to be kind to yourself. And I'll see you all next time. Bye.